Okay, so let's take these three functions and determine which of the following are odd, even, or neither. So we could do this in various ways, but first of all, I think, what can we see? So f is, its x squared is an even function. G is x cubed, so g is odd. Okay. And h is even, because it's the absolute value. The absolute value of minus x is equal to the absolute value of x, of course. So the first one, fg, this is a product of an even and an odd function. So what does that mean? The product of an even and odd function is equal to an odd function. And we could do that from first principles if we wanted, fairly simply. So let's just observe the following, that this is equal to, well, it's f of x times g of x by definition, but that's equal to x squared times x to the 3. That's equal to x to the 5. Right, definitely an odd function. The exponent is an odd number, and that's the only one. Second one. Okay, so let's take a moment to think about this. So this function is g of x plus h of x. So that's equal to x cubed plus the absolute value of x. Now this is a bit of an interesting one because we have a combination. We've got an odd piece, the x cubed piece, but now an even piece, the absolute value. So my gut feeling is because of the blending of the two, it's going to be neither odd nor even. And as I've said before, how should we deal with this? Well, you should just check it at some point and see what happens. It's always the best plan. So let's do it at -1 and see what happens. So at -1, it's -1 cubed plus the absolute value of -1. That's -1 plus 1. That's equal to 0. But the sum at 1 is equal to, of course, 1 cubed plus, well, the absolute value of 1. That's equal to 1 plus 1. That's equal to 2. Taken together, this tells you that f plus g, or sorry, g plus h at -1 is not equal to plus or minus the value at 1. Okay, so what does that say? That is exactly the statement. It's exactly the statement that you are neither odd nor even, because it fails at one position. So tricky, right? The first one we use this general property. The second one we weren't too sure because it didn't fit into our pattern. The sum of an odd and even, we don't know if it's odd or even. We've just checked directly that it's neither.